All right, thank you. It's great to be here. It's my first time. Looking out at the crowd today, in comparison to yesterday, it appears that the networking went really well last night. But I appreciate all the diehards that are here today to learn a little bit more about how to protect customer data. So what I'm going to be talking about is a different approach to protecting customer data in terms of isolation and protection through a technology known as a data privacy vault. And this is a fundamental shift from what historically we've done, which is to protect data in place. And I would say that this is essentially a flawed model, flawed experiment to this point. So through the last 20 years or so of software development, we've taken kind of a cavalier approach to how we build products. This mantra from Facebook, move fast and break things, is something that we've been building tons and tons of technology, amazing technology, and collecting tons and tons of data and doing amazing things with the data. But the actual protection and use of that data has mostly been an afterthought. And that has led to the world that we live in today, which is essentially a data breach happens on a weekly basis. There was, if you've been paying attention to the news, Uber was hacked last week. Someone got in, was posting on their internal Slack channel, commenting on Jira bugs. It seems really funny from an outsider's perspective, but if that is happening to you, I'm sure it's very horrific, as well as a major, major problem in terms of the trust that you built with your customer base. And these breaches are happening all the time. Twilio had a data breach. The IRS in the United States had a data breach recently. The San Francisco 49ers in the city that I live in, American football team, had a data breach of 21,000 social security numbers in the last couple of weeks. I don't know what they were doing with so many social security numbers, but nevertheless, that information is out there now. And we've been collecting all this data, but we've kind of missed the point that recognize that not all data is created equal. Some data, and I'm talking about essentially sensitive customer data, so things like people's names, date of birth, social security number in the United States, banking information, healthcare information. It simply requires better protection than other forms of data. We have all this data that we're storing. Data is the new oil, you'll hear. But a small amount of that information, and it is a relatively small amount, can be used to identify an individual, and if it falls in the wrong hands, can be used to harm that individual, and because that data is highly regulated, can be used to harm our businesses as well, leading to fines and essentially PR nightmares. And the really fundamental thing that we all need to understand, and if you only remember one thing that I say today, I hope it's this, is that this data is special. And because it's special, it should be treated that way. Just like when it comes to special physical documents in our real life. My children's birth certificates, my marriage license, my green card, my passport, those documents are special, and I don't keep them in my kitchen in the junk drawer with my batteries and my flashlights, because those represent fundamentally different things. When it comes to my daughter's birth certificate, that represents a fundamentally different object than batteries. So if my batteries fall into the wrong hands, it's mildly annoying, but it's not that big a deal. If my daughter's birth certificate falls in the wrong hands, then I've failed as a parent. So I keep those special documents in a safe in my home. I isolate and protect them from these other things that are essentially inconsequential. And the same thinking when it comes to protecting sensitive documents that we care about that are special, like our children's birth certificates, our passports, and so on, we need to apply that same thinking when it comes to customer data. Yet where does customer data end up? Essentially, we take it and we stuff it in a database, and then we store it in log files, we store it in data warehouses and data lakes and so forth, and we essentially replicate this information everywhere. And if we look at any sort of system of a reasonable size, they need a lot of stuff to operate today. A business operating today, they're going to have an HR application for managing their existing employees, and an applicant tracking system for managing hiring pipeline, and a CRM for managing their customers. And maybe some of this data is stored in data lakes and data warehouses. And over time, they add additional applications. And each of these applications have dependencies within this graph. And this spider web of dependencies grows more and more over time. And this is a relatively simple example. 20% of enterprise businesses are actually collecting data from over 1,000 different sources. So the number of nodes and edges of this graph is very, very complicated. So why is this a problem? Well, essentially what's happening is this sensitive customer data ends up replicated and fragmented and copied throughout all these different data sources. Imagine if you took your credit card, which is probably stored safely, in your pocket or in your purse or maybe in a safe in your hotel, and you made 1,000 different copies of it, and then you distributed them all around, and you tried to protect all of those different copies. I would highly advise against doing that, but that's a much more complicated problem to solve than keeping a single copy on your person that you're protecting at all times. Yet this is what we do with data. We copy and replicate it everywhere. And that makes it really hard for businesses to answer basic questions like, what data are we storing and where is it stored? The former head of security at Twitter, if you've been paying attention to the news, came out recently and said that Twitter has no idea where your data is stored. And this isn't a Twitter-specific problem. This is basically a problem that most companies in the world are suffering from. And this makes compliance hard, and it makes it really hard for companies to understand whether they're actually keeping people's data safe. So historically, what we've done to try to combat this problem is this essentially duct tape approach to data security, where we take these nodes and these edges of this graph and we sprinkle in some data encryption, we sprinkle in data governance, we throw in a firewall and all these different things, and we're essentially trying this in-place protection model, which goes back to the problem that I talked about of having 1,000 different copies of your credit card and trying to protect all those different locations. That's really, really difficult to do. And it's essentially an intractable problem, which is why we have this plethora of essentially data breaches happening on a weekly basis. So how do you solve this problem? Well, that's a big fundamental question. So if you look at some of the leading technology companies in the world, companies like Apple, Google, Netflix, these are companies that haven't been showing up in the news because of a data breach. Google's there for other privacy reasons, but that's not related to the security of their customer data. And what they did was that they all pioneered a technology known as a Zero Trust PII data privacy vault. And their key insight, which goes back to something I was saying earlier, was that they recognized that their customer data is special. So they took that special data that doesn't belong intermixed with all the regular application data, and they moved it out of their existing systems and putting it into a PII data privacy vault. And what that does is it creates a single source of truth that's isolated and protected from their existing systems, and it essentially descopes their existing infrastructure from the responsibilities of compliance and data security. Sounds amazing, right? So what exactly is the data privacy vault? Well, a data privacy vault isolates, secures, stores, and tightly controls access to manage and use sensitive data. So this principle of isolation isn't something new. If you walked into an office building from 50 years ago, the customer records, the employee records, the financials of the business, they're not just out in the open with the lunch orders of the day. They're under lock and key, at the very least in a locked file cabinet, or maybe in a safe. And very few people within that company have access to that location. That essentially is the non-digital version of isolation and protection and data governance. And we can do much better with modern technology. So principle of isolation is the first part of this idea of a data privacy vault. We need it to live on a segregated network, have privileged access, and every access should be logged for auditing purposes and is also required for compliance. But if you have an audit log, you can apply machine learning to that so that you can actually detect a data breach. Be proactive. A lot of breaches are not detected until months and months after the actual incident. In terms of security, well, we need built-in privacy-preserving technologies, things like encryption, tokenization, data masking. This is core infrastructure. It's your customer data, so you need high availability, throughput, support for structured and unstructured data, enterprise-grade performance. You need to be able to essentially govern access based around the principles of zero trust. So zero trust means that no one and no thing has access until you explicitly give it access. And you need to be able to control access essentially based around the business requirements of the services accessing it. So which rows, which columns, how does it need to see that data? Most of our services and most of the things that we program don't need actual access to customer data or a very limited subset of it. So don't give it access to everything. And then finally, we store this data so that we can use it. It's one thing to lock it up and throw away the key, but it's not very useful. So we need things like built-in privacy-preserving analytics, database-like access, and essentially secure cloud functions so that we can perform operations on the data and pass that data to third parties to do other types of operations. So if we go back to our example here, where we had this problem of essentially what's known as PII sprawl, personally identifiable information sprawl, where it's being copied all over the place. And that makes it really hard for businesses to answer these basic questions like, what data are we storing and where is it stored? Well, that gets a lot simpler when we introduce the data privacy vault, because now, essentially, we have a single source of truth for all that sensitive customer data that's kept outside of our existing systems. And now, if we need to answer a question like, what data are we storing and where is it stored? Well, it's stored in the data privacy vault. And we can look at the schema of the vault to determine what data we're actually storing. When it comes to things like compliance, that question really is now localized to the data privacy vault rather than all of our systems. And for one of the hardest challenges in the world of data privacy, data residency, now we can essentially just shard our customers and deploy different vaults to different regions of the world rather than doing that for our entire data center. So we can have a vault in Europe, a vault in the United States, a vault in Brazil, and so on. And then are we sure that our data is protected and that we're keeping customer data safe? Well, we have a single point of entry through an API. And it's based on a zero trust model. So we can control exactly what access a service has. So the billing application in this example needs a different level of access than the talent app, because they need to actually issue transactions against the customer. So, but the talent app doesn't need to do that, so they shouldn't have that level of access, essentially. Now, this concept of the data privacy vault was pioneered by the companies I mentioned, companies like Apple and Netflix and so on. But they're hard to build. It took Shopify about 3 years and almost 100 engineers to build their version of a vault. So it's a big investment for most companies. It doesn't make sense for most companies to take their precious engineering resources and work on something that's essentially not core to the product offering of the business. So at Skyflow, what we've done is we've taken inspiration from these different companies, and we've built a data privacy vault and delivered it as an API essentially for everyone else. And I talk to startups and of various sizes all the time, and they think that they have a handle on this problem. But if a company like Uber that essentially has unlimited resources, their head of privacy, Nishant Baharia, literally wrote the book on privacy engineering, and they're having all these challenges, well, you probably aren't going to be able to take on this thing yourself, and it doesn't make sense for you to do it. So don't DIY PII, essentially. Because if you do, you're going to be the next Equifax or the next Uber issue or Twitter or any of these types of companies that are having these challenges today. So that is a bit of background about a data privacy vault, where it came from, how it fits into this model, and essentially isolation and protection. But the easiest way, I think, to actually understand how to build modern systems and utilize this concept is to take a look at an application. So we're going to start to dig into an application I built and actually get into a live demo of it. All right, so the application we're talking about is called Instabread. If you're familiar with Instacart, it's like Instacart, but only delivers bread. I made this up, so you won't be able to find this in the App Store, but essentially it's part of the gig economy. So we have bread enthusiasts that want to get on-demand bread delivery. And then you have gig workers or Instabread shoppers that essentially go out to grocery stores or bakeries, get the bread and deliver it to the individuals. And the application that we're going to take a look at is the Instabread shopper or gig worker sign-up experience. So there's a certain amount of requirements that we have. It needs to be mobile first because gig workers are on the go. It needs to be able to essentially allow a gig worker to sign up. So we need secure account or PII collection. They need to select which bakeries and grocery stores they're willing to travel to. They need to be able to put in banking information in a secure way so that we can pay them. And then finally, we want to be able to use modern analytics, machine learning, other types of techniques to actually improve our business. So in terms of the application stack, and most of these are components you could swap out for various other things, the front end of Instabread is built in React. The back end is Node.js. The application storage is DynamoDB, and the data privacy vault is from Skyflow. For essentially the data cloud, I'm using Snowflake. And then for money movement and bank account management, I'm using Move.io, which is a platform for essentially doing money movement and bank management. And in the data privacy vault world, what we're doing whenever we're touching sensitive data, it's happening within the secure environment of the vault, which includes essentially talking to third-party services like a move.io or a Stripe or even an Infobip for sending messages. All right, so we're going to take a look now at what this actually looks like. So I've been here for a couple days. I've attended a lot of talks. I haven't seen anybody do a live demo. So we're going to give it a shot right now. Oops, there we go. All right. So this is Instabread. And we're going to, here, let me blow this up a little bit. Oops. There we go. And we're going to sign up. All right, so I'm going to sign up and put in my name, my email, my zip code, and then my phone number. So I'm registering as a Instabread shopper. Now, ideally, in an application where we're trying to preserve privacy, we want to limit the exposure of our system to any of this sort of sensitive data. So we're going to send that data essentially directly to the vault from the front end. So if we go over to Skyflow Studio here and we refresh our vault, we can actually see this record written in there. And I see this record written as partially redacted and redacted based on the roles and the policies and how the schema is set up for the user that's viewing this information. And the vault isn't just a simple database. If we look at something like email, the vault actually understands the underlying data types of PII, or sensitive data. So it understands that this is an email that has a specific structure. So we can automatically validate data that's going into the email column. In terms of redaction, we can control how data is essentially partially or fully redacted from view. In the case of the email, we're masking that information automatically using this rule. So something like Sean Falconer at Skyflow.com becomes S and a bunch of stars are at Skyflow.com. All data in the vault is, of course, stored and encrypted during transit, but also through a technology that we pioneered called polymorphic encryption, we can actually support encrypted operations. So we can run queries over fully encrypted data, having another level of essentially security where you don't have to decrypt the data in memory and actually in order to utilize it. And then finally, tokenization, which is a powerful technology for essentially substituting sensitive data with non-sensitive tokens. There's lots of different ways you can tokenize data, but in the case of email, what we're using is a essentially format-preserving deterministic token. So every time it encounters Sean Falconer, it's going to generate the same token, and the token's actually going to still look like an email, but it's essentially random strings. And there's no mathematical relationship between the generated token and the original value. So even if someone got the token, they couldn't reverse engineer it. So it's safe to store the tokens, which can act as pointers within our downstream services. All right, so let's go back to Instabread Shopper. So we can get paid to shop, check out, then head out, and so on. All right, so these are the requirements. I have to be over 18, able to lift 40 pounds, eligible to work in the United States, love bread. Of course, who doesn't love bread? I meet requirements. I'm going to choose which places I'm willing to travel to based on my zip code. And again, this information is potentially sensitive, essentially, because most people are going to choose locations that they travel to based on where they live. So we also want to store this in the vault. This is still information that could be used to essentially kind of geolocate or triangulate where someone lives. We wouldn't want that showing up essentially somewhere on the dark web. And then, of course, banking information is highly sensitive. So we're going to put in our banking information as well. And this data is going to go essentially into the vault and then be securely moved over to move.io for essentially payment. So if we look again in the vault here, and we look at the banking information here, we'll see that the bank account information has been written into the vault. All right, so I'm going to continue here. Through the magic of the demo experience, I've already earned $64, so I can cash that out, and I issue the transaction. So that's going to move again securely through the vault, always insulating the system to transfer the $64 from Instabread's business account into my own account. And when we look at the downstream services, in terms of DynamoDB, and I refresh the database here, I can see that there's data stored in here. But instead of the actual plain text values, I'm storing the tokens. So these tokens, again, are pointers or proxies or references to the original values. So I see that the email, for example, is written here, but it's essentially a randomized string. It still looks like an email, so if I have things in place that depend on this looking like an email, I can still create that experience, but I'm not actually storing the data there. And if we go over to Snowflake, and I run this query against our data warehouse, I can see that the data is written in here as well. Oops, wrong. There we go. And I see a JSON blob written with the actual tokens. And I can still run analytics on this just like I would the regular data, because it doesn't really matter that I'm storing Sean Falconer in the data warehouse. All that matters is that essentially every time you encounter Sean Falconer, you're generating the same tokenized form of that data, and then you can still run counts and joins and group bys and all the types of analytical operations that you would do, but without actually exposing your system to the raw plain text values. All right, so that is the quick live demo, and everything works, so that's great. All right, so we're going to dig into how, as soon as my slides load, we're going to dig into a little bit of how this actually works behind the scenes. All right. Oops, doesn't my video back up just in case things didn't work. All right, so as I mentioned, in any technology or any application where we're concerned with privacy and security, we want to de-identify sensitive data as early in the life cycle of that data as possible. So in the Instabread example, that's essentially at collection. In something like an ETL pipeline, that could be ingestion or source creation. So in the application front end, whenever we're collecting sensitive data in Instabread, we're sending that data directly into the vault through front-end SDKs. It's very, very simple. And then the vault sends back those tokenized forms of the data based on how the schema is defined. And then we can use those tokens against third-party APIs as their reference to the original values. So rather than calling move.io directly with the raw text, plain text values, we're calling move.io through the vault with the tokenized forms of the data. And then the vault knows how to detokenize that data securely within the environment and pass that data over to Move. Then we can send the data downstream to DynamoDB, and that kickstarts our ETL pipeline, where essentially we have a Lambda function that triggers whenever new data gets written into DynamoDB, and then a Kafka, and then the Lambda function essentially takes that data, writes it as a Kafka message into the Kafka broker, and sends that down into Snowflake through the Kafka connector, and then we end up with that essentially JSON structure within there. And what we've done is we've de-risked this entire back-end surface from compliance and data security, because there's nothing sensitive stored in here. If someone got into any of these sources, it's just essentially meaningless strings. So there can be certain circumstances, of course, where we might want to be able to retrieve the original values in essentially an analytics scenario. So let's say that we wanted to compute the gig worker density by zip code. Well, we can still do that using a group by on the zip code. And even though the zip code is a UUID, we can still do a group by on that because it's deterministically generated. But we might want to, in the report, be able to render the zip code so that we know where we have our most gig workers. Well, we can do that essentially through a partnership and integration that we support within Snowflake called external function. So we'll take a look at how that works. So essentially, you want to have a data application, and in that data application, you might want to be able to retrieve the original plain text values in memory. So you can do that securely through essentially creating a detokenized function within Snowflake. So the detokenized function essentially can be written into a query. It takes in the token. And then through a feature of Snowflake called external functions, you can have that call a REST API. And that's going to call a secure environment where the Lambda function calls into the vault with the tokenized data. And then essentially the detokenized data comes back. And it's rendered in view. But essentially the IAM rules of whoever's executing that query within Snowflake is connected to the governance engine of Skyflow. So you can essentially do that where the person executing that query is only able to see the limited amount of information that you've given them access to. And you can even detokenize that, not necessarily in plain text, but as partially redacted to whoever you want to control that information. So we're going to take a look really quickly at how that works. So over in Snowflake, essentially you can create a detokenized function like this, and you can see it's going to call essentially this API endpoint. And we don't have time to kind of go into all the details of how this setup works and what the code looks like, but essentially all you're doing is creating a new function within Snowflake where you can write a query, and it's going to know how to essentially talk to the vault. So I can run a detokenize on the email, the first name and the last name, and the first execution might be a little slow because of the cold start of the Lambda function. But essentially, I'm going to be able to pull back the plain text values of the data. There we go. So I see Sean Falconer in my email. And of course, this could be changed based on the requirements that are set up. So I could return this information as partially redacted, for example. All right, so the last thing we're going to get into here is data residency. So this is one of the biggest challenges that companies face when it comes to compliance. Is certain countries in the world require that essentially their citizens' data be housed within their country. And that is a big challenge for a lot of companies that have distributed systems. And essentially, the simplistic way of addressing this is you take your entire cloud data center and you take your customers and you shard them by country, and then you redeploy your entire data center to all these different regions of the world. And I'm assure you, if you did that, AWS and Snowflake would be very, very happy with you because you'd have a really, really big bill at the end of the day. But when you essentially when you use the data privacy vault pattern, it gets much simpler because now the regulated data is essentially housed within the vault. So all we need to do is take essentially US data, deploy a data privacy vault in the US, and pass the sensitive data into the vault, in the US vault, and then same with the EU vault. And then our cloud data center can stay the same because now we're passing essentially tokens downstream, just like we saw before. So this whole distributed or centralized data center is compliant because it's not storing any actual customer data. It's just storing essentially de-identified data. So we're restricting the data residency requirement essentially to the US and EU vault in this case. And that allows us to run global analytics against the Snowflake instance if we want. So this grossly simplifies a really challenging problem that companies are facing. So what happens when you introduce this concept of isolation or protection through data privacy vault is you're really making privacy an architectural decision. And that shifts the entire conversation of data privacy really far left. So that when you are thinking about what database you're going to use, data warehouse, caching system, and so on, you're also taking into account where are we going to store our customer data so that it's protected, so that it's compliant, so that we don't end up with this replication problem, essentially. And as long as you're thinking about it that way, data privacy really becomes as simple as a handful of API calls like we saw in the Instabread example. And the last thing I'll say is that privacy is a fundamental human right. And it's a challenge that every company is really, really struggling to meet today. And I think as founders, as engineers, as architects, people working in the technology industry, it's really important that we take this responsibility of our customer data seriously, and that we are good, essentially, parents to our customer data, and that we're protecting it and doing everything within our power to do that, and not treating it, essentially, like the batteries and the flashlights that we're keeping in our junk drawer. So I want to thank you. There we go. I want to thank you very much for showing up today, listening to me about how to isolate and protect data. If you have questions, I'm happy to take them off the side. I think we're running out of time. But also, if you come up with a question later, feel free to email me, or if you're online. And then also, I host a podcast, which is all about data privacy and security, called Partially Redacted. You can check that out at skyflow.com/podcast. And you can also join the community at skyflow.com/community if you want to keep this conversation going, or this is something that's interesting to you. All right, thank you very much.